Hi students, one more video based on unbalanced assignment problem. Here there are 6 operators and only 5 jobs. That means it is an unbalanced assignment problem. We have to convert it into balanced assignment problem by adding a dummy column. Like that we are going to convert. So in your solution it is an unbalanced assignment problem. We have to make it as a balanced assignment problem by adding one dummy column with cost zeros. Now there are 6 operators and 6 jobs. So what is the least value on each job? In each operator, that means in each row, 0. So what is the first step in the Hungarian method? That is row reduction. So in each row we have zeros. So first step of your Hungarian method has been completed. That means this is the matrix itself which is satisfying the row reduction. Now we are moving on to the column reduction, where for your column reduction matrix we are using the row reduction matrix. So what is the least value of your first column? 2. You are going to reduce that value of 2 from the first column. 6 minus 2, 4. 2 minus 2, 0. 7 minus 2, 5. 6 minus 2, 4. 9 minus 2, 7. 4 minus 2, 2. Now in the second column, what is the least value? 2. So we are going to reduce that value of 2. 2 minus 2, 0. 5 minus 2, 3. 8 minus 2, 6. 2 minus 2, 0. 3 minus 2, 1. And 7 minus 2, it is 5. Now we are moving on to the third column, where in the third column what is the least value? 3. Here, so 5 minus 3, 2. 8 minus 3, 5. 6 minus 3, 3. 3 minus 3, 0. 8 minus 3, 5. And 4 minus 3, 1. Likewise, you are doing the fourth column and fifth column. In the sixth column will be as it is for you. We have been done our column reduction. Now, what is the step 3? Assigning zeros. In your assigning zeros, we are going to give assignment for the column reduction matrix. We are going to write the copy of column reduction matrix and you are going to give the assignment. In the first row, there are 3 zeros. Skip that row. In the second row, there are 2 zeros. Skip that row. In the third row, there is only one single zero which should be assigned. So we are going to give assignment and you are going to cancel all the remaining zeros in that column. So this 0 cancel, this 0, these 3 zeros are also cancelled. Now in the fourth row there are 1, 2, 3 zeros. So move to fifth row. Fifth row already 1 0 is there, that is cancelled. In the fifth row, in the sixth row there is one more 0 which is also cancelled. Now after row examination we have to move to column examination. So in the first column there is only one single 0 which should be assigned. So this 0 is assigned. No 0 will be there in that row. Already this 0 has been cancelled. Now in the second column there are 2 zeros. And in the third column there is only one single 0 which should be assigned. So we are going to give assignment this and we have to cancel the zeros in that row. So this 0 is cancelled and this 0 is cancelled. In the fourth column there is only one single 0 which should be assigned. That's why here it is assigned. Now no 0 will be there in that row. So this 0 is cancelled. Now we got the solution here. But we didn't got the optimal solution. Why? Because there are how many rows? There are 6 rows. How many columns? There are 6 columns. But the number of assignments are only 4. That's why we are going to use chain of marking. That is the next step in your Hungarian method. Where you don't have assignment in the rows, you have to tick that rows. See, these two rows didn't have any assignment. That's why you have to tick these two rows. In these ticked rows, where zeros are there? Only here it is 0. Tick that column. So we are going to tick that column. In the ticked column, where assignment is there? Tick that row. Therefore, ticking is completed. Now we are going to draw straight lines. Draw a straight line for unmarked rows. See, unmarked rows, these are the 3. 1, 2 and 4. And marked column you are going to cut off. So, these chain of marking and drawing straight lines have been completed. So, now we are going to move on to the next step. That's why I have been written that tick the rows which didn't have assignments. In that ticked row, tick the columns which have zeros, and we are going to have in that ticked column where the assignment is there, tick that row, cut the unmarked rows and marked columns. Now the next method is going to have that select the least value from the uncovered elements. So you are going to write the uncovered elements from this matrix. See, select the least value from the uncovered elements. What is the least value? 1. That the value of 1, what you are doing? You are going to subtract that value of 1 from all the uncovered elements, and you are going to add that least value of 1 at intersection of the lines. And those the values which are covered by lines are same. So we are going to write the matrix, that is reduced matrix. How we are going to write the reduced matrix? See, this the value of 4 is covered by line. So you are going to write these values as it is. 4, 0, 2, 0, 1. And this is the value where the intersection of lines is there. That's why you are going to add the least value 1 over here. Now, in the second line, in the second row, 0, 3, 5, 5, 2, and you are going to add that least value 1 at the intersection, that is this. 0, 3, 5, 5, 2, 1. Now, these are the values which are uncovered. You are going to subtract that value of 1. So, 5 minus 1, 4. 6 minus 1, 5. 3 minus 1, 2. 7 minus 1, 6. 3 minus 1, 2. And the last value, this is covered by line. So, you have to write as it is. Now, in the fourth row, all these values are covered by lines. Here it is one intersection. So, same you are going to write 4, 0, 0. 2, 0, and this is an intersection which you are going to write 1. And here it is an uncovered element. What you are doing? You are going to subtract one value. 7 minus 1, 6. 1 minus 1, 0. 5 minus 1, 4. 7 minus 1, 6. 2 minus 1, 1. And 0 and 0. Now, in the last row, these are also uncovered elements. So, we are going to do 2 minus 1, 1, 5 minus 1, 4, 1 minus 1, 0, 4 minus 1, 3, 3 minus 1, 2, and 0 as it is you are going to write. Why it is covered by lines. So, now you got the reduced matrix. In that reduced matrix, you are going to give again assignment. How you are going to give assignment? There is only one single zero. See, in this there are 2 zeros. Now skip to next row. Here there is only one single zero which should be assigned, and no zero is there in that column to cancel. Now in the third row, there is only one single zero which should be assigned. No zeros will be there in that column. That's why we have been cancelled these 2 zeros. In the 4th row, there are 3 zeros, skip. In the 5th row, there is only one single zero which should be assigned. If the assignment is done in row, no zero will be there in that column. So this zero has been cancelled. Now, in the 6th row, there is only one single zero which should be assigned and no zero will be there in that column. This zero has been cancelled. And after completion of row examination, we are moving on to the column examination. So only one single zero is there here which should be assigned. Now we have got the assignment 6. That means now the solution is optimum. And how you are going to find out that? A to B, B to A, C to F, D to E, E to B and F to C. We are going to find out the value of Z by taking the given question. So what is that, ma? Here A to B. A to B is how much in the question? It is 2. That's why 2. Plus B to A. B to A is how much? 2. Now third one, C to F. C to F is 0. D to E is D to E, which is 5. Plus E to B. E to B is how much? 3. Plus F to C, which is 4. Now we are going to add all these values. You got the value of Z equals to 16. Hope you understood this video. Thank you.